So here we go. This is continuation from last time. Here's example 3. Let's do a little warm up. Oh, here we go. Example 3. V is equal to pi r squared times h. And guess what the semicolon h means? Yes, sir? Solve for h is exactly right. Everybody go ahead and do this one. Sort of a warm up, right? This is sort of a warm up. Go ahead, I'll wait. Alright, so who? Tajor, can you show us how to do this? How do I solve for h?
First you have to get rid of pi r squared.
Exactly. Yeah, exactly. So, for example, if I had like something equals to 4x, right? How would you get rid of that 4? Yeah.
Divide into 4.
Divide both sides by 4. Instead of 4, what do we have here, guys? Pi r squared. So we're going to just divide both sides by pi r squared. Right? How many people got the answer? Hold on. This way. And of course, you could rewrite it as h is equal to v over pi r squared. Raise your hand. Oops. Okay. Oops. Here. Anybody forgot this? Raise your hand. Okay, good. Easy enough? Now, this was possible because you had h on one side of the equation only, right?
Yeah.
If you had h on the other side, that would be a different story. Okay, we're going to do that later. Okay, but, right, so that's why I'm going to go over some of those. So if you did, then you have to do something differently, right? But because we had only h on one side, that's easy, right? You just think of it as something, some number times x, and then you just divide both sides by the number. Now, remember when you did your homework last time, I said ignore when they say write the restrictions, right? And now we're going to show you what that means. What do you think it means when they say write restriction? By the way, what does it mean, restriction? Have you guys heard of the word restriction before? Michael?
Is it like you're not allowed?
You're not allowed to, right? Like restricted area, you're not allowed to go in and so forth. So what do you think they mean by write the restriction? How can there be restriction, right? How can something be not allowed for a formula? Does that even make sense? Oh, how about Libby? What do you think, Libby? That's exactly right. This is saying, can a fraction have a denominator equal to 0?
No.
No, right, Claire? So when would this then fraction, when would the denominator of the fraction be 0? When what? When which is equal to 0? H is equal to 0? No, h could be 0. But I'm talking about the fraction. So in a fraction, do we care about the numerator or the denominator becoming 0? Denominator. Can the numerator be 0?
Yeah.
Yeah, that's okay. 0 over 5 is still 0. But what happens if the denominator is 0? It's undefined. So that's the restriction. In other words, we have to be careful when you write these sort of fractions. Formula with fractions. We got to make sure that the denominator doesn't become 0. So how can we? What do we need to say so that the denominator doesn't become 0? Claire, what do you think? Look at the denominator. What's in the denominator of this formula? Pi r squared. So will pi r squared always be non-zero? Meaning, would it ever equal to 0 at any time? When would it equal to 0? Yeah, there are times when this would equal to 0. When will pi r squared be equal to 0? When? Any idea? Okay. Could pi be 0? No, pi is a fixed number, right? It's 3.14 and so forth. So we don't have to worry about that pi being 0. What about r? Can r be 0? Yeah, see, if r is 0, what is 3.14 times 0? 0. So then the whole thing will be undefined. So that's what we mean by restrictions. Do you see what they mean by restrictions? So Bella, what do you think I should write? Because the second part of it says, here's the second part, it says state the restriction. Now, do we know what we mean by restrictions, guys? We mean when we have to be careful so that the whole thing doesn't become undefined. In other words, we don't want the denominator to be 0, right? So Bella, what should we say then? We want to make sure that r doesn't equal to 0 is exactly right, and so this is what you need to write down. So on your homework tonight, even though last night, right, you didn't write down the restriction, now do you think you have to write the restrictions? Yeah, now that I'm telling you how to do them, you need to write down the restrictions. So as you can see, if r happens to be 0, this formula doesn't make any sense, right? You get something undefined, correct? So that's why we need to say r can't be 0. Yes, sir.
Can there be more than one restriction?
Very good. Yes, there may be more than one restrictions. Yes. So we're gonna work on that a little later after this. Yes, sir.
Can we just write that?
So you need to write down what you solve for h equals to v over pi r squared, and then you need to write, what does a semicolon, by the way, mean? Yeah. Yeah, it's just saying I'm gonna write the restriction next to it. Does this semicolon has anything to do with the formula at all? No, it's just you're just separating the restriction and the one that we solve for the variable. So okay, does that make sense? Tajwar, did you have a question?
Yeah. Can there be no restriction?
Can there be no restriction? The answer is yes. When the formula is what? You only get restriction when the formula is written in sort of as a fraction, because that's the only time when you get an undefined number, right? When the denominator becomes 0. Yeah, so if the formula does not, look at our formula, our original formula, right? It has no restriction at all. As it is right now, nothing is undefined or anything like that. Very good. Does that make sense? But if you write it this way, then there's a restriction. Any question there? And some of you said, can the numerator, again, I need to clarify this. Is it okay for the numerator to be 0? Yeah, sometimes people write down the restriction for numerator becoming 0. That'll be wrong. Okay? Restriction is only for?
Denominator.
Yeah, we don't want the denominator to go to 0. Does that make sense? Numerator could be 0, right? 0 over 100. What's 0 over 100? 0. So it's not undefined, it's just 0. Are we okay with that? Yep. May I move on? Alright, here we go. So some of you asked, do you only get one restriction every time? The answer is no. Take a look at this example 4. Can you solve for t and write down the restriction then? Okay, I will wait. It says PV equals to nRT. Okay, so I'll wait for you. Go ahead and solve for t. As you can see, t is on the, we put semicolon and then t. Okay, so it means solve for t. Okay, go ahead. I'll wait. Samuel, what did you do first, please? Can you tell us how to do this? Okay, let's listen now. Divide both sides by n. R is correct. Okay, so then Aaron, tell me what to write. That's right. Now Aaron, did you stop there or did you write down the restriction? Okay, hold on. First of all, how many people got this? PB over NR as T. Okay, most of you. Almost all. All right, Aaron. Do you see anything on the denominator? Look at what is on the denominator. Shh. N and R, and they're multiplying together, right? Yeah. So, is it possible for that denominator to go to 0? Yeah. Aaron, when will it go to 0? When n is equal to what number will the denominator be 0? Because n could be any number you want, right? Which value of n will make the denominator become 0? 0. What about for r? Now, can you write down the restriction? This is only true if, when n and r are not equal to 0. When they are equal to 0, then you get something undefined, correct? There you go. Do I need to say anything about p and v? No, we don't mind for the numerator to become, right, to be 0. That's fine. We just don't want the denominator to be 0. Does that make sense, Aaron? Because then, right, n could be 0, r could be 1 million. What's 0 times 1 million?
0.
0. N could be 1 million, negative 1 million, r could be 0. What's negative million times 0? 0. Therefore, we don't want them to be. Now, does this mean we don't want both of them to be 0 at the same time? Really? No, n could be 0, r could be 1 million, we just said. It doesn't have that. You don't have to have both of them become 0, right? As long as one of them isn't, right? It could be that both of them could be 0, right? But it doesn't have to be that way. Question?
Can you just make it NR?
No. Can you write just NR not equal 0? No, because if you write it that way, then you're not really stating exactly when would NR be 0. You're not really saying that, right? Does that make sense? Yes.
Instead of writing r not equal 0, then n, can you just do r comma
No, just do it this way. It's much better. It just actually shows me that you understand what we're saying. Again, don't write nr equal to 0. Okay, that's not how you write these things. Okay, you need to tell me for each of these factors, right? We don't want them to be 0. Any questions? At this point, I get this kind of question then. If you don't have any question, is it always that something cannot equal to 0? Could it be some number? Is it possible? No. How many people say yes? How many say no? It's always going to be something cannot be 0. Could it be that the restriction, look at all my restrictions, right? It's something, look at all the restrictions we've done so far. It's like some like variable can't be 0, right? Is it always some variable can't be 0? Is that the only restriction? Could it be some number like some variable can't be, like x can't be 5? Could that have a restriction? Yeah, it is. It's possible. Yeah. Let's do an example 5. Let's see if we can understand this. Go ahead. Hold on. Here, try this example 5. It says y times z plus 3 equals to x. And I wrote down solve for what? Solve for y, because I have a semicolon in y. That's what it means, right? Go ahead, solve for y and see. Of course, write down the restriction. From now, if there's a restriction, you need to write it out, okay? I'll wait. So this is an interesting one. Who could tell me how to do this one here? How about, let me call somewhere at random. Matthew, what do I do? Okay, now some of you are saying, you're right. You're actually supposed to divide both sides by z plus 3. Some of you are saying, wait a minute, don't we have to always simplify by distributing y to z plus 3? In this case, that would not be a good idea. Anybody see why that would not be a good idea to actually distribute in this case? Brandon?
Well, didn't you just get like y z plus 3y?
Right, in other words, what happens to y? You had only one y now. What happens? Yeah, if you distribute y, what happens?
You get 2.
Yeah, you get more y's, and it sort of gets hard to actually get the y by itself. Isn't that right? So if you are solving for y, for example, in this case, it would not be a good idea to distribute because you're gonna have y in every different places. You're gonna have it in more than one term and so forth. You know what I mean? So you're right. Let's divide both sides by z plus 3, then you're just basically done, right? Let me see if I could hide the answer because it's no fun showing you. Okay, here you go. All right, now, then who could tell me? Who could tell me the actual answer for this? We're not done quite yet because we have not written down any restrictions. Every time you get every time you get a formula that looks like a fraction, you have to look at the denominator. When will this denominator be 0? How about Christina? Z does not equal to -3 is correct because, class, what would happen? How many people got this, by the way, as your answer? Raise your hand. Okay, good. Most of you. Most of you. If you didn't, do you see why? Bella, what happens if the z becomes -3? Yeah, then the denominator would equal to 0, and could we have something over 0? Is that defined? No. Therefore, we need to state the restriction. Do you see why it's called a restriction? Right? If z happens to be -3, right? You don't even have this number. It's undefined. Does that make sense? Now, some of you say, how do we get that? Well, you can actually think of it this way. This is what I'm thinking in my head. You see a little bubble there? Okay. I'm thinking, when will z plus 3 be? What am I asking myself? I'm asking, when will z plus 3 be 0? And of course, can you solve z by subtracting 3 from both sides or adding -3 to both sides? And as you can see, when z is equal to -3, doesn't this whole thing become 0? Yeah. Isn't this what you're doing in your head? So you could actually write this out if you like. And so as you can see, here's my answer. We need to write down y is equal to x over z plus 3. And as long as z doesn't equal to -3, you're fine. Correct? Do you got any question? So is your restriction always something cannot be 0? No, as you can see, it doesn't have to be that way. Can somebody think of a time when restriction can't be 5? Like, how would you have to have? Like, yeah.
It'd be like
Z, yeah, for this one.
z minus 5.
Yeah, if you have z minus 5 on the denominator, right, then what? The restriction will be z can't be 5. You can make it any numbers you like, right? Can you make the restriction to look like 1? How would you do that? Paige, how would that look like? If I want the restriction to be 1. Yeah, if you have z plus -1 on the bottom denominator, then you know that your restriction is it can't be 1. You can make any numbers you want. Okay, it doesn't have to be 0 every time. Do you understand? Is that clear to everybody? All right, may I give you to example 6? This one is going to be really important because some of you couldn't do the last part of your homework. If you pay attention here today, you should be able to do it. Okay, so let's look at example 6. Take a look at example 6 here. It says R is equal to Jason, AB over A plus B. Okay, and we're solving for what, Jason?
A.
That's correct. Okay, so in this case, this is the type of question that some people have trouble doing. So I'm actually going to do it together with you. So write this down, and so we'll hopefully. By the way, this problem is a little bit. I put 2 stars on this because it's sort of different than the ones we've seen before. Does anybody see or recognize what the difference is in terms of the kind of question that we had before? Dana? Good. A's on, like, they're A's separated, right? All the other ones, there was just one variable that you had to solve for. Here, A's everywhere, kind of. It's on the numerator and also on the denominator. Whereas the other one, it was just in one place, right? Now it's in 2 places. Also, what other things is sort of different? We talked about this, I think, in example 2, when we first talked about this section. What do you notice about where A is? A is on the denominator. One of the A's on the denominator. Remember I told you we don't like for a variable that we're solving for to be in the denominator. That's sort of hard. So what did we say to do? To get it up to the top or the numerator. Do you guys remember how to do this? Chris, do you remember what we did last time? Yeah, we multiply both sides by that variable. Now, does it work in this case?
No.
No, it does not, because it's A plus B, isn't it? If you had A by itself on the bottom, that'd be fine, because then you can multiply both sides by A and things will cancel out. Will A cancel out with A plus B? No. So how are we going to bring it up to the numerator? So that's a little trick. Okay, how about Camilla? You could cross multiply, but we haven't learned that yet. You're right, but we're gonna, yeah, let's not do that yet. But you kind of, Kevin? You cannot subtract B from both sides, because if you subtract B, does it get rid of this plus B on the bottom? No, it doesn't. It's only the part of the denominator, is it? It's not the whole denominator. So you cannot subtract B. These are good questions, but I'm glad you're saying these, because you can't do that. It'd be wrong. How do I get rid of, now let me give you a hint. Think about it as the whole thing like this. Isn't this what it means, really? Remember, fraction bar means it has a hidden grouping symbol, right? Chuck, how do I bring up the A to the numerator?
Multiply A plus B for both sides.
How many people agree with Chuck? Very good, Chuck. That's actually exactly what we need to do. Chuck says multiply, instead of A, multiply both sides by the whole denominator. What is my whole denominator? A plus B. Because then wouldn't it cancel out the whole thing? Very good, Chuck. Excellent. That's what. Actually, go get the medal. You get the medal for that. Yes. One. That's the key step. Chuck has to wear the medal for the. All right, congratulations. Okay, so here you go. Sorry, but you have to give it back after the end. Right? Okay, but still. Okay. All right, look what Chuck's thinking. Look, he says, multiply both sides by the whole denominator. Look what happens when you do this. Does this make sense? Look what happens, right? Multiplying both sides by A doesn't help. Subtracting both sides by B doesn't help. But look, you multiply both sides by the whole denominator. That's the key, guys. You see what we're doing? And so you get A plus B times R equals to AB, don't you? Do you see how the denominator canceled out? Look, all my A's are on the numerators. That's good. But you see how, okay, take a look at what we have here. What should we do next? Angel? Distribute. Should we just divide both sides by B and be done? Because then wouldn't you have A by itself? Why not? You're right, you can't do that. Why can't we just divide both sides by B? Because you have A times B. You can get the A by itself. Carly, what's wrong with that? Yeah, there's still A on the other side. You have to solve for A. Then you haven't solved for A, right? A is still everywhere. So you're exactly right. Only thing that you could do now is distribute. Now, didn't we say distributing makes it sort of make everything, but this time you want to distribute. How come you want to distribute this time? Yes?
Because you're not distributing the A.
Well, even if you're distributing the A, you have to distribute at this point. Does everybody see why? Okay, so you're sort of right, but even if I had to distribute A, you should have done it this way. Why? Yes? Yes. A's have to be on the Same side of the equation. Think about them as family. You want all the A families to be on one side, okay? Does that make sense? You want them to be together. Does that make sense? So you need to, and can I just get this A out of this on the other side when it's in the parentheses? No. How do you get rid of the parentheses? You have to distribute, right? So some cases you have to distribute, right? So in this case, you need to distribute. And now, could we gather the families together? The ones with A's. Brianna, what do I do? Very good. Did you all hear what she said? We need to what? Subtract AR from both sides. Is exactly right. And when we do, you get BR is equal to AB minus AR. Okay, but we got a problem here. So write this down, right? We do, don't we? What's the problem here? Carolyn, what's my problem? Let's try. What are you trying to say? In other words, could we just solve for A right now?
No.
Why not?
Because they have coefficients.
In other words, the A's are in both of these terms.
Yeah.
Is that what you're trying to say? You have A right here in this term, and you have another A on the other term. What are we going to do? Community property? What? Don't we want to just have A by itself? We have A's in both of these terms, right? So that's great that the families are together, right? But we need to get A by itself because we want to solve for A, right? Now, a lot of you have already had your hand up. That's good. Hold on. Think about this. Is there a way, everybody listen, is there a way to rewrite AB minus AR using just one A? Using all the things that we learned so far. I'm telling you that there's a way to write this using only one A. Meaning using, see if we have A's here and A in the other term. Okay, a lot of you, hold on. Okay, I want you to discuss with your group. Okay, see if your groups agree. Tell them if they don't get it. Let's see who could help us rewrite this expression on the right using only one A, because that's the key. All right. How about, okay, a lot of you. Ethan, what do you think? Aiden.
Me?
Yeah.
Well, I divided both sides by B.
If you divide both sides by B, you don't get A by itself, do you?
So, I was going to do B and then R.
Right. If you divide both sides by B and then R, you still don't get, we want to solve for A, remember? So is there a way to write A, B minus AR using A only once? There's a way. Okay, hold on. Put your hands down. Okay, let me call Aiden. Do you remember this distributive property? Aiden? Right? Like A times B plus C, isn't it? A, B, yeah. Do you remember how to go backwards? So you could go, if it's A times B plus C was AB plus AC, right? We could go backwards, right? In other words, what was that before? So do you see how we could go backwards? How would you write this?
So it's A times B minus R.
Exactly right. How many people figure this out? Using the distributive property backwards. Good. If you didn't, write this down. Right, guys? Look, I was able to write down this expression, AB minus AR, right? Using A only once, right? Using distributive property backwards. Why do we do this? Because all you have to do now is to get A by yourself. What? Raise your hand. How about Lindsay? What do I need to do? Exactly right. All we have to do is now divide both sides by BR and you get BR over B minus R equals to A. Is that right?
Yes.
And now, of course, are we done? No, because we have this is written as a fraction. You have to look at the denominator, and this time it's sort of different. Who could tell me the restriction on this? Patty? Shh. B cannot equal to R is correct. Oh, could we write R cannot equal to B?
Yes.
Yeah, same thing. But why do you think I chose to write B first? What's yeah, in alphabetical order, right? You please do them in alphabetical order. Is that okay? So B comes before R, so I solve for B. In other words, hold on, let me finish. In other words, if I had, so this is what I'm thinking in my head. You see how it's in the bubble? think, right? I'm thinking, when will b minus r be 0? Well, solve for one of the variable. Which one am I going to solve for? B or r? B or r? Why r? No, because you want to solve for the variable that comes first in alphabetical order. What comes before, r or b? B. So you want to solve for b, you add both sides by r. It's easier this way. Okay, so you see if b is equal to r, you see the denominator will be what class? Denominator will be 0. Does that make sense? So therefore, this is the correct way of writing this. Okay, when you solve for a, you have to just make sure that not only br over b minus r is what a equals to, but then that you have to make sure b doesn't equal to r, because if it does, the whole thing is
Wrong. Or
undefined. Does that make sense? Okay, guess what? This was actually your homework. Number? Anybody recognize this? This is number 27. So if you guys had trouble, listen, class, may I have attention? If you had trouble doing number 27, here's how you do it now. If you had other ones that you had trouble with, if you know how to do 27, you should be able to do the other ones. By the way, guys, let me ask you this. What's a good way to actually know whether or not you got this or not? How can you practice and see if you got this? You do this on a blank sheet of paper. See if you can do it yourself. Any question? Yes, question.
Oh, okay.
Let's listen to the question, class. Here you go. Yes.
Whenever we're writing the restriction for for example 6, like b does not equal to r, do we have to write negative r cannot equal to b?
Okay. No, that would be wrong. Why would that be? Why would you? Okay, so listen. The question is, can we write, is this same as negative r cannot be b? Where did you get that from? What would that be? No, class, listen. Let me ask you this. If you write this, Carolyn, you'll be wrong. Look, I'm solving for b right now, right? If this will not get you 0 in the denominator. If b was equal to negative r. Look, plug in b equals to negative r. You get negative 2r. That's not 0. Okay, so this will be wrong. You just basically look at the denominator. This is what you do. If you ever get questions like this, make this whole thing on the denominator equal to 0, and solve for one of the variable, whatever comes before in alphabetical order. And if you solve for b, you add r to both sides. You know that b equals to r. That's the restriction. Okay, that'd be wrong if you wrote b cannot equal to negative r or something like that. Okay, because then you get negative 2r. That's not 0. Do you understand? Any other question? Do you understand? Class, do this if you ever get confused, okay? Solve for the 0 on the denominator. Okay? Any questions? Alright.